Okay, so we've made it to week 3, and this week we're going to be talking about body composition and nutrition. So just to start off, I want to do a little just basic overview of body composition. So this is what we're going to be going through over the next few slides. But to start off, if we're going to understand body composition, we need to understand the terms of mass, weight, volume, and density. Okay, so I'm not going to answer this question, but I want you to think, first of all, have you heard that fat weighs more than muscle? And so the question that I've got for you, and the question I want you to think about very carefully, and I think is on your quiz, is what weighs more, 5 pounds of fat or 5 pounds of muscle? Now we'll answer that question when we get to class on Tuesday. So to start off, mass is just the amount of matter that an object has. The weight is how much, how gravity or the effect of gravity on that object, right? So we weigh less. We would weigh less on the moon than we would here. However, our mass would stay the same. The volume is how much space that object or that thing or you are taking up. And the last one is density. Okay, so density is how compact or how concentrated, I guess might be a different way to look at it, an object is. And so the formula for density is mass divided by volume. Okay, so we can have two things that weigh 10 pounds, but the more compact something is, the denser it is. So just imagine if we had something the size of a golf ball and something the size of a softball that both weighed 1 pound. Well, the golf ball would be more compact. Now, when it comes to body composition, it's very difficult to determine completely or perfectly or accurately someone's body composition. And that's because it's a prediction. You can't actually measure the tissues directly. All right, so Trevor shared with me that a good analogy to use for this is the weatherman, okay, or the weather people. Okay, when you watch the news and you see the meteorologist or the weather person get up there and say what's going to happen the next day, this is all based off modeling, based off predictions. Okay, and so with a prediction, you always make assumptions, and so the better your assumptions are, the better your prediction is. The worse they are, the worse your prediction will be. But you also have to take into account the number of assumptions that you make. The more assumptions you make, the more likely you are to have error. And so kind of a very simplistic way of looking at this is, let's just say you have two assumptions, and the first assumption has an error rate of 5%, and the second one has an error rate of 5%. Well, then you can make an argument that your prediction is only going to be 90% accurate, okay? I'm not going to get into the math. It's a little bit different than that, but yeah, we'll go with that. And so with body composition, we are using different models to describe or estimate body compositions, right? So it's prediction. And so body composition, when we do this, we have a lot of assumptions. Everybody's not the same. If you don't believe me, just look at people. They're all different, okay? And this can be due to biological sex, race, among other things. So to start off, I want to give you an idea about density, and this, I think, plays into that question I asked earlier about fat and muscle. The different things that make up our body have different densities. Okay, and so water is kind of the typical standard. 1 gram of water takes up a milliliter, okay, and that's actually a centimeter by a centimeter by a centimeter, so a centimeter cubed. If we take that same volume, a milliliter, and we just fill it with fat, well, it's only going to weigh 0.92 grams, whereas a muscle weighs 1.06. Bone has a pretty high density. Blood has a slightly higher density than water. Now, I want to make clear that I'm not going to ask you on the test, hey, what's the density of muscle? But I just want to show this to you to let you know and to kind of give you something visual and something quantitative to show that densities are very different. Okay? And some things, such as bone, are very, very compact, very dense, and then you've got fat kind of on the other end of the spectrum. So when it comes to these body composition models, we can kind of at the basic level, do two things. One is we take the two-compartment model. And with the two-compartment model, basically what you're doing is you're breaking your body up, or breaking the composition of your body up into fat mass and then everything else. Okay? And this is one that's most commonly used. It's it's relatively easy. And when people determine protein requirements, they do it off this fat-free or this lean mass. Now, the problem is that we assume that all fat mass has the same weight or density. And as we just showed you on the previous slide, that's not the case. Bone is very dense, whereas muscle, not so much. Blood, is a little more dense than water, but bone kind of changes the equation a little bit. Okay. And that says fat mass. And so that's not entirely true either. And then I just went through fat-free mass, where we've just shown that the density varies by what we're talking about, whether it's bone or teeth or blood or whatever. But even fat, there's some different densities depending on the type of fat. And so what's the issue with this? Well, if we assume that all fat mass weighs the same, and if we assume that all fat-free mass or lean body mass weighs the same, well, that's not accurate. And so even if we use equations based on this, it's not going to be correct. There's going to be some error. All right. And so this is just kind of a picture to look at the two-compartment model. And so another model that we've got is what's called the four-compartment model. And so we've got fat, lean body, so think muscle, mineral, which includes bones and teeth, and then we've got water. Okay, again, that's not completely the same, but it's going to be better. But there's still some error that's going to be with that, right? And then you need to realize that men and women are very different. So we've got 45% versus 36% muscle tissue. You've got essential fat versus non-essential fat, bone, and then you've got your organs and things like that. Okay, so even four-compartment model doesn't necessarily take into account all the different densities. But it's the reason we have to do this, the reason we have to model this, is because we can't just cut someone open and calculate their body composition and put everything back together like nothing happened. Okay, but body composition can actually play a role in sport performance, right? And so they've actually come up with optimal, like tables that give you optimal body fat percentage by sport. Okay, and so as you can see here, they vary widely. So marathon running, right here. So this is me, 5 to 11%. I'm a long distance runner. It means I need to lose some fat weight. I think I'm closer to 15 last time I checked, which was a long time ago. But that's kind of optimal. Whereas, you look at a lineman on a football team, we're up to 19%, or shot putters, 20%. All right. And so it varies by sport. And so we're going to end right there. And we're going to kind of dive into the way we can actually determine or calculate body fat percentage.